Yeah, Shashi. Yeah.
Okay. Otherwise, it is 2 hours, right?
Yeah.
It's
Correct. Yeah.
yeah. I'm in CST. Okay. It's last training. It was very good. Only like after this thing, no daylight saving, it
Hmm.
became little late for me.
Okay.
So,
No. Yeah. So we'll get started maybe. I mean, in the last session, we were discussing about performance engineering life cycle. So from there, I will start my explanation. So in continuation to the previous session, in that previous session, we were discussing about when developers are actually doing, I mean, architectural understanding. That time, performance engineers will do architectural review. Okay. So in that case only, I wanted to explain like what is scale up or scale out means what, horizontal scaling means what, vertical scaling means what, like that. Because so I mean, when you are trying to understand your architecture, it is good that you are thinking about these aspects also. I mean, your scale up means what, scale out means what, all those things we need to understand it. Say a typical example, say you feel like your application is actually slow, your application is actually slow. That time you wanted to do some kind of improvement. I mean, the infrastructure improvement you wanted to do. Say say like the initial configuration of my machine is actually somewhere like 4 GB. Initial configuration is somewhere like 4 GB. So I wanted to improve my configuration to see something is actually giving some kind of a benefit or what. Say like I'm improving the 4 GB RAM to 8 GB RAM. I'm getting some kind of a change, but yet to see lot more changes. Okay, I wanted to improve from 8 GB to 16 GB RAM, 8 GB to 16 GB RAM. So I'm getting little more important improvement, and then I'm changing it to 16 to 32 GB RAM, 16 to 32 GB RAM. Okay, so I'm getting some amount of betterment in my activity. But after some time, if my chipset or my motherboard is not supporting, okay, my chipset or motherboard is not supporting this kind of an I mean upgrade. Okay, upgrade. So whatever happening till now is actually called a scale up. All these are actually called as your scale up. You are increasing your configuration to make sure you are getting some kind of improvement or what, scale up. Scale up, or it is otherwise called as vertical scaling. Vertical scaling, it is otherwise called as vertical scaling. Okay, so which means that from so and so configuration I'm trying to improve to so and so configuration, and till the level of my motherboard or chipset is actually supporting, right? That is actually called as your vertical scaling or your scale up. Scale up. Okay, and you reach to the level and then you are unable to increase your configuration because your motherboard is not supported, right? So in that situation, say like you are having one more similar copy of 32 GB machine, one more similar copy of 32 GB machine, and putting these two machines under load balancer, putting these two machines under load balancer, this is actually called as scale out. Scale out. Okay, this concept is actually called as scale out. Okay, you are adding one more similar copy and putting it under the load balancer. That is actually called as scale out, or the other name is horizontal scaling. Horizontally you are scaling the infrastructure. Horizontally you are scaling the infrastructure. Horizontal scaling. Horizontal scaling. Any question, guys? Any question, guys? Anybody have any question in this? So actually saying, guys, instead of thinking about straight away changing the code level, that is the usual thing everybody is doing. What everybody is doing? Everybody is doing They are thinking that first of all we need to fix the code. First of all, we need to fix the code. Actually saying don't go to that path in the first angle itself. Try to do other things like these things, like heap size increase, or infrastructure increase, or your configurational changes or something like that. You try to do it. If it is not actually working fine, that time only you need to think about code level. You need to think about code level. Okay, so this
But,
also
but
you are going to think during your architectural understanding. Okay,
Shravan,
what is your, yes.
always it is not the case, right? So if the application performance is not good, if I increase from 4 GB to 8 GB, it may not increase the performance of the application, right? So it
It
depends
is
on.
not. Yeah, good, complete your question. Yeah.
Yeah. So my question is simply like if I increase from 4 GB to 8 GB, I may not get the good performance. Am I right?
That's what even I'm also telling that you are not going to get the good performance, but you are not degrading your performance.
Okay. Yeah.
Okay, if you are increasing it, you are avoiding the things to go in the wrong direction. That is what I'm saying. You're getting my
Okay.
point.
Yeah. But it
Yeah.
is we should not suggest this to the client. In the sense, we should not tell that okay, performance is bad means I should not tell okay, increase the RAM from 4 GB to 8 GB or 32 GB. That is the wrong suggestion to the client, right? I should not do that.
You can suggest it. You can suggest it. How you have to suggest it is that, like, now the machine that we are having is a low configuration machine. Because of that, our heap setting, our heap size is actually very small. So if you are increasing your RAM size, so you can in turn increase your heap size. If you are increasing the heap size, your memory management will be good. Because of that, your application is going to work fine. That kind of a recommendation you can give.
Okay.
You're getting my point.
Yeah, yeah, sure.
Uh, Hi, sir.
Yes, yes, Preeti.
So here, if it is like you said, like we shouldn't go directly to the code first, right? So we have to check on these memory issues first. So what kind of symptoms we can observe at the beginning? So out of a load test analysis, what symptoms will be there for this kind of memory issues, sir?
Yeah, definitely a good question, Preeti. So usually, say like you are going to monitor your yes,
No,
yes.
sir, I didn't speak anything.
Somebody
I think.
asked in the middle.
Okay.
Okay, no problem. Whenever you are observing your memory graph, if your memory graph is going in this way, if your memory graph is going in this way, actually saying your memory graph supposed to go like this, in parallel to your x-axis. In parallel to your x-axis, your memory graph should go.